Students, our topic is integration by substitution. First of all, I would like to uh, analyze the question. If you take a look, we have a secant square and then we have some domain 5x plus 1. And if we analyze this, if we know the integral of secant square, x is tangent x. So if we turn this secant square 5x plus 1 into one variable, so what we need to do is we need to substitute that 5x plus 1 equals to t. And if we differentiate at both sides, it will turn into 5 dx plus 0 equals to dt. And the whole integral will turn into secant square t, and this part will be, you can see it's a 5 dx equals to dt. So 5 dx can be replaced with dt, and now it is a very straightforward integral, which is tangent of t plus c. So what we need to do, we need to substitute the value of t. So it will be tangent of 5x, oh sorry, tangent of 5x plus 1 plus c, and this is our solution. In this question, if we see what we have in domain, in the domain we have square root of x square minus 3x plus 1. So what we are going to do, we will replace x square minus 3x plus 1 equals to t. And when we differentiate, it will turn into 2x minus 3, and this part 1 will become 0, and then we can write dx, and that is equals to dt. So if we see the whole denominator we have here can be replaced with dt. So it will be limit 3 to 5 dt over square root of t, which can be written as 3 to 5 t raised to the power negative 1 by 2 dt, and this can be replaced with t minus 1 by 2 plus 1 over minus 1 by 2 plus 1. We have applied the power rule, and that is equals to 3 to 5, and that can be turned into t raised to the power 1 by 2, and then you have a 1 by 2 at the denominator, which can be moved to the numerator, and again we have a limit of 3 to 5. Now what we need to do, we will apply the limit here. So we'll take the constant out, and we will say square root of 5. We are plugging the value of the upper limit in t minus the lower limit, square root of 3. So we can calculate that in your calculator, and that's your answer. So you can keep this answer, or you can further go to solve it in your calculator. In this question, you can see the denominator. We have 8x minus x square, and we have nothing at the numerator side, and we can substitute. We can put 8x minus x square equals to t, and if we will do that, we'll get 8 minus 2x dx, which is not, 8 minus 2x is not existing at the numerator side. So what we are going to do, we'll apply some strategy here. So we will take the whatever we have inside of the square root at denominator, which is minus x square plus 8x, and we will take negative 1 out from here. It will turn into x square minus 8x. Now we will complete the square here. it will be x square minus 8x. We will divide the coefficient of x, which is negative 8, with 2, and then we'll take the square, which will be negative 4. So we negative 4 square and 4 square is the same thing. So we will say 4 square minus 4 square, and that can be turned into like this: x square. We can directly write something here. That is that part. You can see here, that is x minus 4 square minus 4 square, and that can be turned into 4 square minus x minus 4 square. And we know there is a formula, there is a rule, which is a square minus x square is sine inverse x over a plus c. So you can see here, if we plug it here in the integral, if we use this space here, so if we plug this value 1, that is dx over 4 square minus x minus 4 square. So you can see, and we'll put a square root on the top. So you can see we have a constant square minus variable square, which can turn into sine inverse x minus 4 over 4 plus c, which is a constant of integration, folks. Okay, folks, if we analyze this question, in the denominator we have x squared plus 1, x squared plus 1 whole square. So we will take only the part which is inside of this bracket. So that is x squared plus 1, and we'll put it equals to t. Now if we differentiate, it will be 2x dx equals to dt. And if we divide 2 at both sides, it will turn into x dx equals to dt over 2. So instead of x dx, we will replace it with dt divided by 2, which will 1 by 2, which will be like this. So it will be dt divided by 2 divided by t square, which is, we can take 1 by 2 as a constant out of the integral. It will be dt over t square, and that is 1 by 2. And we can apply the power rule. We'll take t square to the numerator, it will turn into negative 2, and we'll apply at the same time I have triggered the integral. So negative 2 plus 1. And this is, you have 1 by 2, and then you have a t raised to the power negative 1 divided by negative 1, and that is equals to negative 1 by 2 into 1 by t. So folks, this is our solution. And no, sorry, this is not our solution. We need to plug it the value of t, negative 1 by 2, and that will be equals to 1 over x squared plus 1. So we need to plug it back. We need to plug the value of t, whatever we have substituted. In this question, folks, you can see here, you can see we have something in the square root, which is x cubed plus 5. So if we replace this, if we substitute x cubed plus 5 equals to t, and if we differentiate it both sides, it will be turned into 3x squared dx equals to dt. So you can see here, this part and dx can be replaced with dt, and this is negative 1 to 1, and then it will be square root of t dt, and we will apply the integral here. We'll trigger the integral. It will turn into negative 1 into 1, and we have 1 by 2 plus 1 and 1 by 2 plus 1. So it will turn into 3 by 2. At the denominator, it will be 3 by 2. So that will be flipped. When it will go to the numerator side, it will be 2 by 3, and you can see it is 3 by 2 here, and we have -1 and 1. Now all we need is to plug the value. Instead of t, we will plug the value 1 and -1. So it will be 2 by 3, and you have 1 raised to the power 3 by 2 minus into -1 raised to the power 3 by 2. So any, if you have, if you can plug it into your calculator, and you can calculate this part. In this question, what we need to do again, we need to substitute 2x squared plus 3 equals to t. So we'll substitute that 2x squared plus 3 equals to t. And if we differentiate at both sides, now it will turn into 4x dx, that is equals to dt. But our purpose here is not fulfilling. You can see here, we have -8x, but we have a 4x here. So how we can turn into -8x? Very simple. You need to multiply -2 at both sides. So it will turn into -8x dx equals to -2 dt. So you can see here we have whatever we have at the numerator sides, that can be replaced with -2 dt. So that is -3 to 0. So we are replacing -8x dx with -2 dt, and that is 2x squared plus 3 can be replaced with t raised to the power 2. And if we come here, it will be integral of -3 to 0, and -2 can be taken out as a constant, and we have a dt over t square. If we trigger our integral here, it will be -2, -3 to 0, t raised to the power -2 plus 1, and -2 plus 1. I have applied the power rule. So it is -2, and we have a -2 plus 1, which is negative, so it will turn into positive. And this is, we have -3 to 0, t raised to the power -1, which can be written as +2. You don't need to write +2. It's, if it is nothing, it means plus. So we have -3 to 0, 1 over t. And then when we apply the limit, it will be 2. And you have 1 over 0 plus, upper limit minus the lower limit, which is 1 over -3. So folks, you can see here 1 over 0 is infinite. So it is making, when you have, let's say you have a few drops of water in the sea, that these few drops will be considered the part of the sea. And when something is infinite, your answer becomes infinite. So your answer in this case is infinite.